In today's video, we're going to again discuss the traveling salesman problem, which is essentially having a starting point or depot and going to a set number of locations and back to the starting point in the shortest distance or amount of time. I'm going to go through an example of the traveling salesman using something called simulated annealing. Simulated annealing is a probabilistic optimization technique inspired by the physical process of annealing, where a material is heated and then gradually cooled to reach a state of minimal energy. In the context of the traveling salesman problem, simulated annealing is used to find a good, but maybe not optimal solution to the problem of finding the shortest possible route that visits a set of locations and returns to the starting point. I'll briefly go over the code. You can pause the video if you'd like to see it. It's pretty basic. Essentially, we're going to import some various libraries. We're then going to generate random locations. There's then going to be a distance calculation function. Then the simulated annealing algorithm with intermediate steps for animation. Generate a neighboring solution by swapping two locations. Then the acceptance probability. Store intermediate results for animation. Cool down the temperature. Stop if temperature is too low. Add the parameters. Run the algorithm. Set up the animation. Scatter plot for locations. Line plot for routes. Update function for animation. And then create the animation. So I'll go ahead and run this now and just kind of let it sit as it goes through and calculates the solution using simulated annealing. That brings us to the end of the video. As you can see, there are 499 iterations. This simulated annealing does not necessarily give you the most optimal solution, but it is a technique that you can use to solve certain optimization problems. Thank you very much for watching the video and have a great day.